From lights to complex digital fuel injection systems, electricity is the lifeblood of a vehicle's electrical system. This video covers what electricity is, how it's produced, circuit types, basic testing, and tips for diagnosing problems. What is electricity? One of the most common forms of energy, electricity is an invisible force created by the movement of electrons. Electrons are particles found inside atoms. Along with electrons, atoms also contain particles called protons and neutrons. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge. Protons and neutrons make up the center of the atom, called the nucleus, with electrons circling outside the nucleus. If an atom has the same number of protons and electrons, it is balanced and has a neutral charge. When an electron gets knocked out of its orbit, it becomes what's called a free electron, and the atom losing the electron then becomes positively charged. If the free electron finds a balanced atom, the atom becomes negatively charged. An atom that is charged either positively or negatively is called an ion. If the free electron joins an atom with a missing electron, the atom becomes neutral. Particles with like charges repel away from each other, while those with opposite charges attract. The continuous transfer of electrons between atoms and the resulting attraction or repulsion of the atoms makes electrical energy or current flow. In the electrical systems on Kawasaki vehicles, electrons get knocked out of their orbit in two ways: a chemical reaction inside a battery, or by the magnetism of the vehicle's charging system. A battery is an electrochemical device that converts chemical energy to electrical energy. The chemical that brings a battery to life is a solution of sulfuric acid and distilled water called electrolyte. A reaction between the electrolyte and the lead plates sets off a chemical change, an exchange of electrons, which in turn establishes a strong negative electrical charge in the battery. Since the rest of the battery has a lack of exchanged electrons, the battery therefore contains both negative and positive charges. During the discharge cycle, electrons are transferred from the electrolyte to the negative plates. From there, the electrons travel out through the negative terminal to the vehicle's electrical components, and then back into the battery's positive terminal where they are accepted by the positive plates. During the charge cycle, this process is reversed by the vehicle's charging system, or a battery charger. The electrons are driven onto one side of the battery again. In the magnetic creation of electricity, a magnet is moved past a coil of wire. As the north and south poles of the magnet pass over the wire, it knocks electrons in the wire out of their orbit. This produces voltage, which will then result in current flow. A more in-depth look at the creation of electricity can be found in the video reference manual. There are two ways to describe current flow: electron theory and conventional flow. Electron theory states that current flows from negative to positive. This is the scientific explanation for what actually occurs. Conventional flow states that current flows from positive to negative. This way of thinking is mostly used when performing diagnostics work. While both are valid ways to describe current flow, conventional flow will be shown for the remainder of this video. There are two types of current: direct and alternating. Direct current, or DC, is current that moves in one direction only. Shown in waveform, DC current only produces positive voltage. Produced by batteries and DC generators, DC current powers items like lights, horns, ignition systems, and others. With alternating current, or AC, current flows in both directions. In the AC waveform, both positive and negative current are produced. AC current is produced by an AC alternator, or generator, and must be rectified to DC before the vehicle's DC electrical system can use it. There are three units of electricity: amperage, voltage, and ohms. While each one is described individually, it's important to know that each one has an influence on the others. Amperage is the amount of free electrons flowing, It can be thought of as the flow rate of electrons and is measured in units called amps. Voltage is the pressure at which free electrons flow. Also known as electromotive force, voltage is measured in units of volts. The ohm is a measurement of the opposition or resistance to electron flow. Components such as light bulbs, coils, switches, and even the wire that carries the current all cause resistance. Now that you've seen what electricity is, let's take a look at how it gets to where it's needed. A circuit is an electrical pathway that starts at a power source, travels through a wire to a component, and back to the source. To start with, there must be a means to create the electricity, or a source. This is usually the vehicle's battery, generator, or alternator. From the source, the electricity travels through a conductor, like a wire, to a component or load. A load is anything that converts electrical current into another form of energy, such as light, heat, or movement. From the load component, the current travels through another conductor, through a ground, and back to the source. It's important to note that current must return to the source in order to complete the circuit. A closed circuit with both a positive and a negative connection must exist in order for current to flow. If the circuit is open, caused by a broken or disconnected conductor, a faulty component, or a failed source, current won't flow, and the load or component will not operate. It's also essential to understand that circuits have both a negative and ground side. The negative side of a circuit exists between two components and eventually leads to ground, or a common. The ground side of a circuit goes directly to ground. One special note: the color coding of the ground wires will be the same for all grounds, while the color coding on negative side wires varies. This difference is important to the troubleshooting process, as some diagnostic tests are done on the negative side of a circuit. There are three basic types of circuits: series, parallel, and series parallel. In a series circuit, all of the system's components are connected together plus to minus, one after another. If just one component fails in a series circuit, all the components will stop functioning. In a parallel circuit, each component is tied together plus to plus and minus to minus, so the current to each component has a separate path. If one component fails, the other components continue operating. A series parallel arrangement combines both types of circuits into one. In this system, operation during component failure depends on which component fails. Now that we've seen what electricity is and how it gets to where it's needed, let's look at how to find and repair problems in electrical systems. A few basic tools go a long way when it comes to troubleshooting. One tool that's a must-have is the correct service manual for the year and model vehicle you're working on. The wiring diagrams, testing procedures, and component specifications contained inside the manual are invaluable. In addition, most service manuals have wiring diagrams of individual electrical systems to help simplify the diagnostic process. Another essential tool is a multimeter, which is designed to measure units of electricity. Always consult the instructions included with the meter for proper operating procedures. The basic layout of a multimeter consists of a set of positive and negative test leads, a function selection switch, and a display screen. Most troubleshooting on a vehicle is done with the multimeter in either the DC voltage or resistance mode. To check for voltage to a load component, connect the test leads to their corresponding sockets, then turn the selection switch to the required DC volt range. The DC portion of the meter will be marked with the letters DC or have a straight line with some dots under it. When selecting the range, choose a setting slightly higher than the maximum voltage of the system. In most cases, this will be around 20 volts. Now, using the vehicle's wiring diagram as a guide, connect the positive test lead to the positive side of the component. Connect the negative test lead to the negative side of the component and observe the reading on the meter. The voltage reading will depend on what the circuit's operating voltage is. If it's a 12-volt circuit, the reading should be approximately the same as the battery. If voltage exists but the component doesn't work, then the component should be tested. Some circuits, such as a camshaft position sensor, are 5-volt circuits. For this reason, always consult the vehicle's service manual in case there are specific testing procedures. If no voltage is detected, connect the positive test lead to the positive side of the component and the negative test lead to the battery ground. If there is still no voltage, the problem exists between the component and the source, in this case, the battery. To find the problem, trace the positive side of the circuit from the power source to the component, checking for voltage at any connections or additional components. Where the voltage stops indicates the problem lies between that point and the component. Now perform a continuity test, which we'll explain later in this video, on the wires from that point to the component and make any necessary repairs. If power does exist on the positive side of the circuit, then the problem is on the negative side of the circuit. It's important to note that on some circuits there are 2 voltage tests, loaded and unloaded. During a loaded test, a component is left connected to the circuit, while in the unloaded test, the component is disconnected. Always consult the vehicle's service manual and perform both tests if required. A continuity test is used to check the continuity of a wire. To perform the test, turn the selection switch on the multimeter to the ohms setting. Either the word ohms or its symbol will mark the ohms setting. Choose a range around 200. Now, with the positive side disconnected, touch the positive test lead to the ground side of the component. Take the negative test lead and connect it to a suitable ground. If the reading on the meter is 0, the circuit to ground is good. If the reading is infinity, a broken, corroded, or loose wire exists. To find the problem, trace the circuit from the component to the ground source, checking for continuity between connections. Repair or replace any faulty wiring. Another useful test to perform is a resistance test. A resistance test measures how much a component or circuit resists the flow of electricity. Procedures for testing the resistance of each individual component can be found in the vehicle's service manual. Generally, the multimeter will be set in the ohms mode in the required range. With the component disconnected, the test leads are then connected to the appropriate terminals. The reading on the meter should reflect the specification in the service manual. If the reading falls outside the specifications, it must be replaced. To test the voltage output of an AC component like an alternator, turn the selection switch on the multimeter to the AC setting, choosing a range just above the maximum voltage output of the component. Now, use the procedure in the service manual to connect the meter's test leads to the component's output wires. Start the vehicle, then compare the reading on the meter to the specifications. These are just a few ways a multimeter can be used to perform diagnostics on an electrical system. Consult the vehicle's service manual for information on additional testing procedures. Following a few simple tips can make troubleshooting an electrical system a whole lot easier. Always check to make sure the battery is fully charged before beginning any work. Make sure all connectors are clean and tight. Start the diagnostics process by checking the simple things, such as a continuity test on the fuses. Many tests can be done without taking apart the whole vehicle. For example, when checking a circuit that receives its operating voltage and ground from the ECU, perform the test at the ECU connector. Using the vehicle's wiring diagram, locate the wires coming out of the ECU to the component. Now perform a voltage test to see if the component is being supplied voltage and a ground. This eliminates the possibility that there is a problem between the supply and the ECU. Always test a component before replacing it and perform all of the tests described in the service manual to verify the condition of the component. Remember, a circuit must be complete in order for current to flow and operate components. This program has covered basic electrical theory, circuit construction, multimeter operation, and electrical system troubleshooting tips. For additional information on Kawasaki electrical systems, refer to the video reference manual included with this program. Employees of authorized Kawasaki dealers can earn a completion certificate for this program by taking the corresponding quiz on the K-Tech Learning Center section of the K-Dealer website.